Okay, this video is going to focus on naming compounds in a systematic way, which is called nomenclature. There are different rules for different types of compounds, and you guys must be able to name all 6 of these classes. The first one is polyatomic ions, second is ionic, the third is molecular, the fourth is acids, the fifth is hydrates, and the sixth are organic compounds. For polyatomic ion naming, what are polyatomic ions? They are covalently bonded compounds, which means they are sharing electrons amongst themselves. But as a group, they have lost or gained electrons, so they have a charge. You have to memorize them. I gave you a list of them when you received your summer assignment, and you are responsible for knowing all of them. So for example, do you know what Cr2O7 2- is? Because I do, and it is dichromate. The second class you have to know are ionic compounds. Ionic compounds are made up of a metal and a nonmetal. It could also have a polyatomic ion that takes the place of either the metal or the nonmetal or both. These compounds are formed from the transferring of electrons. Once there is a transfer of electrons, one ion is positive, which lost the electrons. We call that the cation. The other ion is negative because it gained electrons. We call that the anion. And they are attracted to each other because opposites attract. We call that electrostatic attraction. When you want to name these, this is the general format. You put the name of the metal, or the polyatomic. You put in the parentheses, it's a little off there, but in the parentheses you put the Roman numeral. If it's a transition metal, or one of the exceptions that I will talk about, that Roman numeral represents the charge of the metal before it. After it, you put the name of the non-metal, and you have to put the ending of "ide." When you are naming ionic compounds, you need a Roman numeral for anything that's a transition metal because they can have various charges. They can have multiple charges. They are also used with tin and lead, even though they're not transition, because they have variable charges. You might want to circle them on your periodic table. Tin is number 50 and lead is number 82. When you want to find the Roman numeral for a metal and you have a compound already given to you, you're going to take the number of negative ions, multiply it times the charge of the negative ion, and you'll get a number. Then you divide that number by the number of positive ions. So what I'm saying is, if you have a situation where you have something you do not know the charge of, so let's say it's SnC2O4, okay? The first thing you look at is the negative ion, which is the oxalate here. How many oxalates do you see? And be careful, it's not 4. There is one oxalate, times it by the charge of the oxalate, which you have to memorize. The oxalate is a 2-, so times it by 2 and you get 2. And then you divide it by the number of positives. How many tins do you see here? Divide it by 1 and you get a 2. Now I don't require you to use this formula, it's just helpful if you need to know how to do it. So here's another example of how to find the charge of the ion. So in SnO2, there are 2 oxygens. So 2 oxygens times the charge of the oxygen on the periodic table, which is 2-. 2 times 2 gives you 4, and then you divide by the number of tins, which is 1. 4 divided by 1 gives you a 4. You write a Roman numeral 4 in parentheses, and you get tin 4 oxide. Another example, CrBO3. Now, how many BO3s do you see? There is no parentheses, that means there is one BO3, times the charge of borate, which is a 3-. You get 3, divide by the number of chromiums, 1, you end up getting chromium 3 borate. Last one, vanadium, and then you got to find out vanadium's charge. 3 fluorines times the charge of fluorine, which is 1-. 3 times 1 is 3, divide by 1, you get vanadium 3 fluoride. Now, there are other ions that are transition metals but do not get Roman numerals because they only have one charge. You need to know not only what they are, but which charge they have. The nice thing is they are clumped together on the periodic table. The 3 happen to be zinc, cadmium, and silver. They form this nice little backwards L. Zinc and cadmium, which are on top of each other, are both 2+, and silver is a 1+. So here we go. You need a periodic table. Ca, calcium. Oh, I'm sorry. Ca is calcium. So you write down calcium, then decide, does calcium need Roman numerals or not? It is not a transition metal, so do not put Roman numerals, and then you must know the name of C2H3O2 yourself. If you've memorized them, you will know that that is acetate. And the second one, Ag, is silver. Silver is a transition metal, but it's one of those exceptions we just went over. It does not require Roman numerals. So do not put Roman numerals, and then to name sulfur, you add that IDE ending, sulfide. The next one, Mo, is molybdenum. Molybdenum is a transition metal, so you need Roman numerals. PO4 is phosphate. And if you want to find out what the charge of the molybdenum is, there are 2 phosphates times the charge of phosphate is a 3 minus. 2 times 3 is 6. Divide by 1 molybdenum, and you get molybdenum 6-phosphate. Next one, Fe is iron. Iron requires Roman numerals. Phosphate we just talked about. You have 2 phosphates there. 2 times the charge of phosphate is 3. 2 times 3 is 6. Divide by this 3 though, and you get iron 2-phosphate. Calcium we talked about does not need Roman numerals, and the name of OH is, if you memorized it, hydroxide. Next one is lead. Lead is one of those exceptions that although it is not a transition metal, it needs Roman numerals. SO4 is sulfate. You have 1 sulfate times the charge of sulfate is 2 minus. Divide by the number of leads, you get lead 2 sulfate. K is potassium. Potassium is not a Roman numeral needing metal because it's not transition. And then the F is named as fluoride. Last one, NH4 is ammonium. Nothing special needed to be done for a polyatomic. And then NO2 is nitrite, and you are good. If you have to go the other way, okay, you need to be able to know their charges quickly. Cadmium, for example, is one of the ones you must memorize. Cadmium has a charge of 2+. Permanganate you were supposed to memorize, MnO4-. Swap and drop, and you get CdMnO4 2. Aluminum has a charge of 3+. Nitrate has a charge of 1-. Swap and drop, and you get AlNO3 parentheses 3. Iron has a charge of 2. Chlorine has a charge of 1. Swap and drop them, and you end up with FeCl2. Chromium has a charge of 3. They're telling you. Phosphate, you must know, also has a charge of 3. They will reduce, and you end up with CrPrO4. Ammonium, make sure you memorize, is NH4+. Carbonate is CO3 2-. Swap and drop, and you get NH4 2 CO3. Now for molecular compounds. Molecular compounds are formed between nonmetals only. So ionic have a metal, molecular do not have metals. The bond is held together not through the transferring of electrons, but through the sharing of electrons. When you name a molecular compound, you name it by using prefixes. These prefixes indicate how many atoms are present, and then for the second element you add "ide." The only other rule you need to know about the prefixes is do not use mono on the first element, but you can use it on the second element. You must know the prefixes by heart. Here they are. They should also be obtained in or contained in your notes, so you can reference them at any time. These are easy. Do not, I repeat, swap and drop these. So when you see prefixes like di and mono, you should go, oh, this is so much easier. All you have to do is go dichlorine. That means I have 2 chlorines. Monooxide means 1 oxygen. Done. That's it. Okay? N and F, now I know I need to use prefixes because N and F are both nonmetals. They're both on the right of the periodic table. There is 1 nitrogen, but do not use mono on the first element. So it's nitrogen. And then because there's 3 fluorines, I'm going to use tri, and then instead of fluorine, fluoride. Third one, di and tetra remind me that I should use prefixes, or I should not swap and drop. Dinitrogen means 2 nitrogens. Tetra is 4, so tetroxide means 4 oxygens. The last one, tetra, not phosphide, but phosphorus. You only use ide on the second one. Deca, sulfide. Acids. Acids will begin with an H, or they will contain what I like to call the Cu group. The Cu group is a carbon, 2 oxygens, and a hydrogen bonded together in that order, and it's usually at the end of a compound. The way you name it depends on what is after the H, okay? If whatever is after the H ends in ate, ite, or ide, it changes how you name the compound. So if what's after the H ends in ate, you change it to blank-ic acid. I always tell students, I ate the icky stuff. That's how you can remember it. The ites will become OUS acid, and the ides are hydroblank-ic acid. Notice the major difference between the first one and the second one is the presence of hydro in the last one and not in the first one. Okay? That's how you can tell if it came from ate or ide, because the endings are the same. The only way you can tell is the beginning. So in the first one, what's after the H? That's the question. After the H is CN. CN is cyanide, IDE. So when you change it, it becomes hydrocyanic acid. Hydroblank-ic acid. Sulfurous, when you're working backwards, notice it ends in OUS. OUS means it came from ITE. So what was sulfite? If you've memorized it, sulfite is SO3 2-. You know that the acid tells you there's an H in front. H has a charge of 1+. Swap and drop, and you get H2SO3. So you are swapping and dropping acids. Notice the only time you haven't swapped and dropped so far is molecular. For the third one, H2S, I know it's an acid, there's an H in front. This is sulfide, okay, IDE. So I'm going to change it to hydrosulfuric acid. Now, the next one, I notice it ends in ic. I'm going, okay, is it an ate or an ide? And I see the hydro. That tells me it came from iodide. Iodide is I, and it has a charge of 1-. I put a hydrogen in front for the acid, and I end up with HI. The next one, PO4, is phosphate. If it's an ate, it changed to ic. Now, a lot of students will tell me it's phosphic acid, but that just sounds terrible, so we add an extra syllable, and we get phosphoric acid. The last one, acetic. It ends in ic. There is no hydro, so it came from ate. Acetate was C2H3O2-. Put an H in the front for the acid, and I end up with HC2H3O2. Hydrates. Hydrates are ionic compounds that have water attached. Now, naming them is really quite simple because it combines the rules for not only ionic but also molecular naming. Generally, when you name it, it looks like this. Just like it would in an ionic compound, you have the metal, then possibly a Roman numeral, then the nonmetal with the ide on it, and then the prefix plus the word hydrate. So, if you look here in the first one, name this first part separate from the second part. Fe is iron. Iron needs a Roman numeral, chloride. Now, using the formula I taught you, there are 3 chlorines. Chlorine has a charge of 1. 3 times 1 is 3. Divide it by the 1 iron, and you end up with iron 3 chloride. The second part is even easier. How many waters do you have? 6. Look back at your prefix chart I gave you, and the formula, or the prefix for 6 is hexa. Hexa, and because of the water, hydrate. Sorry, I'm out of room. For the second one, for the second one. Manganese has a charge of 2. They're telling you. Manganese has a charge of 2. I'll work up here. Bromide is Br with a charge of 1 minus. So swap and drop the beginning. Treat the beginning different from the ending. MnBr2. Tetrahydrate. Put a dot right in the middle of the compound. And then tetra means 4. So we have 4 H2Os. Third one. Ca is calcium. Calcium does not require a Roman numeral. Sulfate is SO4. Di is the prefix for 2. Hydrate. Last one. Copper has a charge of 2. Acetate you have to memorize. Swap and drop, you get Ca, C2H3, O2, 2. I'm sorry, not Ca, Cu, C2H3, O2, 2. And monohydrate means 1 water. The last compound group. Now I know my students did not learn this, so this will be new for you guys, but you should pick up on it easily. Organic compounds are defined as compounds that are made up largely of carbon. If you go to chemistry in college, you may have to take organic chemistry. I won't begin to tell you how much fun that is, but it really does revolve a lot around carbon. There are a lot of classes of organic compounds, but I expect you to know these 3 classes only. Alkanes, alkenes, and alkynes. And notice they only differ at the end. Ane, ene, ine. Keep that in mind as we go forward. When you name an organic compound, there's a combination of 2 parts. A root, which is the beginning, that will tell you how many carbons there are in the structure, and then a suffix that will tell you if it's an alkane, an alkene, or an alkyne. So in my example, the pent tells you there's 5 carbons, and the ene tells you it's the alkene family. Here's a table of prefixes that you must know for the number of carbons. You'll notice that many of them are similar to the molecular prefixes after you get to number 5. Up until number 5, though, they're different. So instead of mono, it's meth. Instead of di, it's eth. Instead of tri, it's prop. And instead of tetra, it's bute. And you must know those. Alkanes are made up entirely of carbons and hydrogens. If you look at all 3 pictures, you'll notice that they all contain single bonds. To know the formula for an alkane, you need to know that it's CnH2n plus 2. So what that means is, okay, for example, propane. Prop means 3. That means there's 3 carbons, and if you plug that 3 into the formula, you end up with H8. So propane is C3H8. Alkenes are made up entirely of carbons and hydrogens as well. Alkenes contain a double bond between some of the carbon atoms. Now, there is more complexation with naming these, but what I want you to know that the general formula is CnH2n. So for propene, the prop still means 3, it'd be C3H6 instead of C3H8. Alkynes also can be a little more complicated with naming, but in general you need to know that they are also made up entirely of carbons and hydrogens. They contain a triple bond between their carbons somewhere within the molecule, and the general formula is CnH2n minus 2. So with propine, it would be C3H, 2 times 3 is 6, but minus 2 is 4. So here are the ones I expect you to do, okay? Now ethene. The ene tells you to use the CnH2n formula. Eth tells you 2, so C2H2n would be C2H4. Ethine, okay, is CnH2n minus 2 because it's an ine. The eth tells you it's a 2, so it's C2H2. Propane is CnH2n plus 2. The prop is a 3 for 3 carbons, so you get C3H8. Meth is 1 So when you plug in one carbon, you end up with CH4. And then the very last one, bute, 4 carbons, C4H, 4 times 2 plus 2 is 10. So it's C4H10. That is it, and that is all you need to know for this lesson.